Many thanks, Rosita, and thanks very much, Anthony. Good morning, Europe, and good afternoon, Asia, and thanks very much for taking the time to come and listen to our presentation today on automated twist lock handling, the final piece of the puzzle in terminal automation. Rosita, have you got the slides up there? That's great. If you could go to the next slide, please, Rosita. So we have developed a machine to automate the handling of twist locks, and we'll show you it working today. We'll also discuss with you some of the key considerations in the automation of twist lock handling within a container terminal. Automation of twist lock handling is not simply a matter of buying a machine and putting it in there. There's a large range of other conditions and considerations that you need to have in order to automate this in a container terminal. In my discussion today, I'll give you the background on pinning and container operations. I'll show you an overview video of how this technology could fit into a container terminal. There's many other ways that it could fit in. We'll show you our machine working, the robot working, moving, removing and fitting twist locks. And then we'll discuss some of the implementation considerations, potential issues, and some of the features of the machine that would need to be considered if you were to automate twist lock handling in your operation. Next slide, please, Rosita. So very simply, twist locks join containers together on a vessel. They are needed to secure the containers when they're at sea, and they need to be removed and fitted by stevedores when the vessels are at port, either loading or discharging. Next slide, please. The problems with twist lock handling are it's a very hazardous operation. You can see in these photos some of the hazards that the stevedores face. It's also, as well as being risky, there's significant cost involved, and it slows the operation down. Next. There's roughly 2 billion twist locks handled manually by stevedores on the quayside or somewhere within the port every year. So it's a very significant cost burden to the industry, and it's something that the industry has been looking to automate for many years, but it's quite a difficult task to automate. Next slide. As I said, some of the drawbacks of manual twist lock operations are that it's dangerous, that it is expensive, and it also is inefficient in the crane operation. In some cases in the USA, there's 4 men deployed per each corner, and each of them are paid $600 a shift. That gives you quite an extreme example of the cost involved for some container terminals. Next slide, please. One of the reasons that this task hasn't been automated is the very large number of twist locks in circulation. There's between 50 and 80 different types of twist locks deployed on all the different vessels sailing into container terminals. And one of the reasons is the vast array of these. It's very difficult to have a machine which caters for all of them. And what we'll show you today is a solution to that. Next slide, please. So I'm just going to show you a brief part of this video. If you could press play, please, Rosita. This is just one example of how our technology would be deployed in a container terminal. The machine would consist of a steel frame based on the sill beam of the crane. A container is landed onto that steel frame. Underneath that would be a number of robots which move underneath the container and remove or fit the twist locks. Once they're removed from the container, they're placed in a storage magazine underneath the frame, and they're stored there until they're needed for reloading back into the machine. The machine will remove 2 twist locks in 22 seconds. If the terminal desires to have that done faster, additional robots and hands can be deployed. Once the twist locks are removed or fitted, the container can be taken to the horizontal transport and delivered into the yard. There's a number of different configurations for key cranes, tandem key cranes, second trolley. Our machine can fit into all of those situations. This configuration shows two of the machines in position. As I said, there's many different ways this could be configured, not only with a tandem operation. So that's all for that video. Thanks, Rosita. If we could move to the next slide. So what you're seeing here is our 10-foot prototype. It's built in a laboratory in Singapore. It consists of the following features. On the top, you'll see an orange-coloured mock 10-foot container with 4 corner castings, which is resting on a blue steel frame onto which the container would land. In the middle of the screen, you'll see a white 7-axis robot. This is quite a standard off-the-shelf robot. There's nothing particularly clever about it. Where the cleverness starts is on top, you'll see a silver and black master effector, which connects to a range of different hands or end effectors, of which there's about 12 to handle around 50 to 60 different types of twist locks. On top of that is the silver end effector, which is specific to that twist lock. It has a geometry and design which is specific to 1 or 2 types of twist locks. It runs on a track, so it's able to travel 10 or 20 feet. And next to it, you'll see the storage magazine, which is much smaller than it would normally be, but for prototype purposes, the storage magazine is fine. So if we move to the next slide, Rosita, and we can press play. No, one back, please, Rosita, you've gone too far. Yep, press play, please. So what we're demonstrating here is the PinSmart machine removing 4 fully automatic Hi-O twist locks. These twist locks are some of the most difficult to handle. They involve 3 actuations in one. When it's being removed, you have to grab a catch, pull the catch down and turn the twist lock in one motion. So we're demonstrating this particular twist lock because it is quite complex. As I said, the robot will remove 2 twist locks in about 22 seconds. This video is slightly slowed down so I've got time to explain it. It then travels the 10 feet to the other end of the container, would be 20 feet in the case of a normal container. It will remove the other 2 twist locks and place them into the storage magazine. It will remember where it stored them, and it will remember to go back to that position and get that particular twist lock when it is required for backloading. Okay, thanks, Rosita. If you go to the next slide, there's another video where I'll be able to demonstrate some other features of the machine. If you could press play, please, Rosita. Imagine if you'd now moved from over-deck operations with the fully automatic twist lock, and you're now moving under deck, and you've prescribed that there's hatch cones. A technician will send a message to the machine that he needs to change over from one particular end effector to another one. In effect, he changes from hand 1 to hand 2. He gets the new hand out of the storage rack, and now he's able to handle the type of different hatch cones that you see in the adjacent photograph. This particular end effector is able to handle 4 different hatch cones, as you can see here. And hatch cones are a very different challenge to twist locks because they're much smaller and they've got different catches and levers on them. So all the work that RAM has been doing is specifically in relation to all these different types of fiddly little twist locks. So the machine has just fitted one twist lock to the corner casting, and in this demonstration we're fitting and removing just so you can see in one motion. And now it's going to grab a different type of hatch cone from the storage rack, and it's going to fit it into the corner casting. And as I said, out of about 50 to 60 different types of twist locks, we have between 12 and 14 different end effectors or hands, which are in storage racks on the machine to cater for the full range of twist locks that you'll see. So I have many other videos that I could show you, but that just demonstrates the changing between hands and the ability of the machine to handle a range of different twist locks. So thank you, Rosita. Next slide, please. So that takes us to the end of part one. As those of you who are familiar with automation will know, 99% of automation is boring and it works very well, but the major considerations occur around the handling of exceptions. So for the 0.5% of the time, when you're planning for automation, you need to plan for these other exceptions. So if you go to the next slide, please, Rosita. What I'd like to do is take you through some of the common type of exceptions that you may handle when you're working with endeavoring to automate the handling of twist locks. So there's I'll run you through the top 5 type of exceptions that you may experience when you're handling twist locks and trying to automate them. RAM has experience from 2006 when we built our first machine. So we've got a vast array of hours and days and weeks of sitting on cranes, watching machines handle twist locks. So we're very familiar with the type of problems which occur when this happens. So if you could go to the next slide, please, Rosita. What you can see here is a range of different problems that may occur. So in the top left-hand corner, you have a problem where you have a container which has come down from the ship with what we call a 3-pointer, where you have 3 twist locks in the box, but one is missing in one corner. So how does the machine cater for that? So we have a particular program. The machine will recognize that there's a problem here. And then depending on our planning with our customer, the machine will then automate a technician in a remote location who has a video, and he'll be able to see a picture like this. And from a drop-down menu, he'll be able to select and tell the machine what to do to solve this problem. Another example is in the bottom right-hand corner is where you have 3 twist locks of one type, and the ship has a mix of twist locks on the deck, and it's given you a wrong twist lock in one of the corners. Our machine will be able to recognize this. It will then be able to send a message to a technician, and the technician will be able to give the machine a message from a drop-down menu about how to do this. One of the final examples that I'll deal with is what many people will be familiar with is jam twist locks. So often the twist locks will have been at sea for a long time, they're salty, or there's something else has gone wrong and they're not able to be moved. Well, firstly, our machine is much stronger than a human hand, so it can deal with more of them. But it can't deal with broken twist locks. So again, a message will come to an operator. He will then instruct the machine on how to deal with that. And the man-machine interface in the planning of any automation is one of the most critical topics. And I'm sure if you speak to someone like Michael, who's been dealing with this for the last 20 years, he'll be able to tell you that automation works well 99.9% of the time. And it's the exceptions planning when you're planning for automation that's critical. So next slide, please, Rosita. So I just wanted to show you some of the considerations when you're planning for the automation of twist lock handling and some of the things that need to be considered in planning for that type of operation. And then if I go to the last area for consideration when you're talking about twist lock handling, if you go to the next slide, please, Rosita. There's a number of points that need to be considered when you're automating this technology into your container terminal. Firstly, you have to consider the integration with the cranes, how it talks to the spreader, where it takes its power from, how it integrates with the CMS on the crane, what part of the cycle is automated when you're landing on this machine, how the machine then talks to the crane when it's safe to lift off. You also need to consider integration to existing systems in the container terminal, for example, the TOS and the planning systems. So the planning system needs to talk to the crane. It needs to say that this box needs a twist lock. It needs to say what type of twist lock it needs. It then needs to speak to the PinSmart machine and advise it that this is the type of twist lock that it's getting, and the machine needs to configure itself in advance of that box coming so that it can plan for it. The third area for planning is the man-machine interface, and this involves by far the biggest area of consideration, is when men are interacting with the machine. So there's two areas where they're interacting. One is the logistics of twist locks. So if there's an imbalance between discharging and load, if you're discharging 1,000 boxes but backloading 1,500, you need to consider the logistics of the twist locks, how you're taking them from the vessel, and sorting them and putting them into the storage magazine in advance. And then finally is the service support. This job's done manually now. You're removing some men from the operation, but you're adding machinery. So you need more technicians, you need to train technicians, and they need to be servicing the machine and keeping it at a high level. So there's some of the major considerations when automating for twist lock handling. And then the final slide, I'd like to finish up. I'd like to thank you for listening to us today. My final slide shows you a typical scope of supply for a fully automated twist lock handling machine. We have a prototype built. We're in detailed discussions with several large terminal operators, and we're currently taking orders for automated twist lock handling machines to be integrated into a terminal with a 12-month delivery time. If you're interested, please feel free to contact me. Again, thank you very much for your time.